Alright guys, this is lesson 103, and in lesson 103 we're going to start with a little bit of review and give you some different notation that maybe you haven't seen before. Hopefully you have, make it a little bit easier. But first and foremost, we want to start by identifying domain and range and telling whether something is a function or not. So for number one, we've got this nice easy ordered pair, list of ordered pairs here. In order to identify the domain, we're going to look at the first values or first entries or inputs, and we're going to list that out in roster or list notation. So I notice my first inputs, I've got a 1 and a negative 1 and a 1. Don't list things twice, no need for that. Just list everything that you see once. Alright, so there's my domain. The set of inputs is just 1 and negative 1. My range is the set of outputs or the set of second entries. So I can look up here and see I've got a negative 2, a negative 2, and a 9. Again, don't list things twice. There's my range, negative 2, 9. That's my set. That's a set of outputs. All right, third thing is we want to identify if this thing is a function or not. Remember, the question that you're asking yourself is, does every input have one and only one, or one unique is another way to say that, output? Okay? By input, you could think of that as x's if you want, if you're more comfortable with that. By output, we're looking at y's. So to answer this question for this particular problem, does every input have one and only one output? Well, to do that, we're going to check the domain. So here's my first input, 1. 1 has an output of negative 2 in this ordered pair, and we go over to this third ordered pair and 1 has an output of 9. Therefore this is not a function, because make sure you list the reason when you're answering these questions. 1 has outputs of negative 2 and 9. Okay? So let's move on to the second one. The second one's a little bit different in that it's given to you using different notation, but if we really look at what's going on here, we know that that this notation, this f of x or g of x notation in this particular case, all this means is that this is the input. This is the value that you're going to plug into the function g. G is just a name for that function. So we're going to plug in 2. And when I plug that in, my result is 5. Well, that's just a different way of representing an ordered pair. So what this really means, this representation is I've got an ordered pair here of 2, 5. Input, output. Over here, I've got another ordered pair of 6, 0. Input, output. Another ordered pair of 10, negative 5. So this is really just a different way of representing the same type of thing that we did in number 1. So let's go through the same process. Now that we've got it listed as ordered pairs, go through the same process. We want to identify the domain. My domain in this case, again, is the list of all input values. So I've got the set of 2, 6, and 10. Those are my inputs. All right, my outputs that are related to those, that's my range. My range is the set of all outputs. So my outputs are 5, 0, and negative 5. So there's my domain and range. And now again, we want to check to see whether this is a function. Is this a function or not? We're asking the same question. We're going to look at the domain or the inputs and see if those input values map to one and only one output. So let's check our first one, 2. 2 maps to 5 in this one, and we don't see 2 come up as an input the rest of this example, so 2 checks out. Second input is 6. 6 maps to 0 and only 0. That's the only one, and same thing with 10. 10 maps to negative 5 and only negative 5, so our answer is this is a function, since every input has one and and only one output. Alright, so those are the easy ones. Down here a little bit more challenging. I want to think a little bit more abstractly on this one. So what we have here is kind of a funky function here. So in this function, what we want to do is we want to identify the domain. So remember, when we're talking about domain, we're talking about input values. In other words, what values of x can I plug in or use and get an output that works. And this is not a technical definition. Instead of that works, we're really talking about a real number output. Okay? So we're looking at what values can I plug in, what values can I plug into this and get something out of it, have this function h of x spit out something that works. And in this case, what I really want to draw your attention to is the denominator. If you plug something, a particular number into that denominator, in particular 2, you can't plug a 2 into here. Why? Because h of 2, when I plug in h of 2, I get 1 over 2 minus 2, which is 1 over 0, and we know that this cannot happen. Okay? This, in particular, this value of x, when x equals 2, I don't get a real number. I get something that's undefined because we know we can't divide by 0. So this is one case where we would have a restriction on our domain. That happens to be the only number that you can't plug into this thing and get a real output, a real number for an output, or get something that works. So we're going to look at that set notation again. We're looking at real number values of x, so all the x in the real numbers, such that, or where, x is not 2, because that's the only one that works, or that does not work. Okay, so what this means is basically I can use any number as an input except for 2. 2 is not an input. Any number works except 2. So x can't be 2. The range happens to be all numbers. I'm not particularly concerned. I'm sorry, all real numbers. So we would just say the set of x in the reals. There's not really any condition on that, so we can just write it like this.